In this lecture, I am going to present what is fixed arch and what are the advantages of fixed arch over two-hinged arch and how to solve the fixed parabolic symmetric arch problem. Then I would like to explain one problem on fixed parabolic symmetric arch. First, we have to know what is fixed arch and what are the different advantages of fixed arch over two-hinge arch. Fixed arch is also known as hingeless arch. There are two fixed ends at both ends, and it is a statically indeterminate structure. In fixed arch, there are 6 unknown reaction components, that is 4 forces and 2 end moments. By using the condition of equilibrium of static forces, only 3 unknowns can be evaluated. Therefore, other 3 unknowns remain as redundant. So, the degree of static indeterminacy of a fixed arch is 3. Then, what are the advantages of fixed arch over two-hinge arch? The advantage, that is, the positive moment near the center of the fixed arch is much smaller than the positive moment at the corresponding location in a two-hinge arch. In the case of fixed arch, the positive moment near the center of the span is smaller than the positive moment at the corresponding section in the two-hinge arch. So this is one advantage. Then the deflection of the fixed arch is somewhat less than those of the two-hinge arch. So the deflection of the fixed arch is also less than what is the deflection of the two-hinge arch. For long span arch, the smaller deflection of fixed arch is an important advantage. So these are the advantages of the fixed arch over the two-hinge arch. Then coming to the symmetrical fixed arch. This is x-axis and this is y-axis, and this is the elastic center. O is the elastic center. So here the fixed arch is symmetric with respect to the y-axis. This is the y-axis, and this is the moment at the elastic center MO, and this is the vertical force at the elastic center VO, and this is the horizontal force at the elastic center HO. These are the forces. These forces can be found out using this formula. So these are the 3 forces. MO is the bending moment at the elastic center O, and VO is the vertical force or vertical direction at the elastic center O, and HO is the horizontal force or horizontal direction at the elastic center O. And these 3 redundants can be found out using this formula. MO is equal to minus integration m dash ds by ei divided by integration ds by ei, and VO is equal to minus integration m dash x ds by ei divided by integration x square ds by ei, and HO is equal to minus integration m dash y ds by ei divided by integration y square ds by ei. MO, VO and HO can be evaluated using this equation. After knowing VO, HO and MO, the moment at any point can be determined by static equilibrium equations. So after getting MO, VO, HO, then the moment at any other point can be determined by the static equilibrium equations. Then coming to the analysis of fixed parabolic symmetric arch. Already I have explained in the previous lecture the analysis of fixed parabolic symmetric arch. This is the rigid arm. This is connected to the support A and the elastic center O. So what is the force at the elastic center O? So that is equal to the fixed end A. So VA, HA and MA is equal to the VO, HO and MO. This force you can find out using this relation. MO, VO and HO Then after getting MO, VO and HO, then the moment or the forces that you can find out at any section using the static equilibrium equations. So in the case of fixed parabolic symmetric arch, the elastic center is on the symmetric axis. This is the x-axis and this is y-axis. So y-axis is the symmetric axis. So in the case of fixed parabolic symmetric arch, the elastic center is on the symmetric axis, that is at a height h by 3 below the crown. So this is crown and this is the elastic center. So the elastic center lies h by 3 below the crown. If the elastic center is taken as origin, the equation of the parabola will be y is equal to yc minus 4h by L square into x square. So this is the equation of the parabola. Then y is equal to h by 3 minus 4h by L square into x square. So using this equation for a parabolic arch, the values of MO, VO and HO are the elastic center O may be determined, and moment at any section may be determined using the equation of statics. Then coming to the problem, a fixed parabolic symmetric arch of span 30 meter and the central rise is 6 meter has a moment of inertia at any section I is equal to IO sec theta, where IO is the moment of inertia at the crown and theta is the inclination of the tangent with horizontal. Find the reactions at the support when the arch is subjected to a load of 240 kN acting at a distance of 6 meter from the left support. Determine the moment under the load and at the crown. So this is the fixed arch, and here the load is present at a distance 6 meter from the support. The load is 240 kN, and this is the x dash and y dash axis at the crown. The span of the fixed arch is given 30 meter and the rise of the fixed arch is given 6 meter and the load is given 240 kN, and you have to find out what is the moment under the load and at the crown. So first you have to find out what is the redundant at the support A, that is VA, HA and MA. So for the VA and HA and MA, so first you have to connect the rigid arm support A and the elastic center O. So what is the moment and vertical force and horizontal force at the elastic center? So after getting this, the vertical force, horizontal force and the moment at the elastic center, then you can find out the moment at any section in the fixed arch. This is the basic determinate arch, the cantilever arch with the free end at A. After taking the redundant VA, HA and MA, so this becomes the cantilever arch with the free end at A as shown in the figure, and this is the load is present. This is the basic determinate arch with the external loading 240 kN. Then, so what is the redundant at VA, HA and MA? So after connecting the rigid arm between the A and O, O is the elastic center. So what is the vertical force or vertical reaction, horizontal reaction and the moment at O? So after getting this VO, HO and MO, then we can find out what is VA, HA, MA, and similarly VB, SP and MB, and at any section you can find out what is the moment after knowing the VO, HO and MO. So this is the fixed arch and this is the rigid arm. Let O is the elastic center. Let O be the elastic center as shown in figure 3, connected to end A by the rigid arm. Let MO, VO and HO be the moment, vertical force and horizontal force respectively acting on the elastic center. This is the vertical force and this is the horizontal force and this is the moment acting on the elastic center. This is the h by 3. From the crown to the elastic center, this height is h by 3. So this is equal to 2 meter. The total rise is given 6 meter. The elastic center to the crown, this is h by 3. This is 2 meter. And the span is 30 meter and the load is present 9 meter from the crown. that is 240 kilonewton at the point D. This is the basic determinant arch with rigid arc OA. Now O is at a distance h by 3 below C, already I have explained. So that is h by 3 is equal to 6 by 3 is equal to 2 meter. So this height, that is from crown to the elastic center, this height is h by 3. So this is equal to 2 meter. Taking elastic center O at the origin and the xy axis as shown in figure. Taking elastic center O at the origin, and this is x axis and this is y axis. Then the equation of the arch you can find out, y is equal to h by 3 minus 4h by L square into x square. This is already I have explained in the previous lecture. Then after putting the h and L, we can find out the relation y is equal to 2 minus 1 by 37.5 into x square. This is the relation of the y and x for the fixed arch. The equation of the fixed arch is equal to y is equal to 2 minus 1 by 37.5 into x square. The moment in the determinant arch due to given loading, that you can find out and you can denote by m dash, and here in the determinant arch due to the external loading, so what is the moment between A and D? So here there is no loading, the moment between A and D is equal to 0. And what is the moment between B and D? So here you see, this is the origin and this is the x axis, this is y axis, and the load is present here 240 kilonewton from the crown. Let us take from the origin x distance. So what is the moment here? What is the moment here? The moment here is equal to minus 240 into 9 plus x. So from this axis, what is the moment due to this 240 kilonewton load? So this is x and this is 9. So the distance, the perpendicular distance of this load is x plus 9, and the moment about this section is equal to 240 into x plus 9. The direction of the moment is anti-clockwise. So this is your equal to minus 240 into x plus 9. So this moment is between B and D, and the integration limit is from minus 9 to plus 15. From the O origin to the point B, so this distance is 15 meter, and from O to D this distance is 9 meter, but this is in negative side. So here the integration limit is from minus 9 to 15. So m dash is the 0 in portion AD, and m dash is equal to minus 240 into x plus 9 in portion DB. This is the moment between A and D, and this is the moment between D and B. But we know the moment at the elastic center and the vertical force at the elastic center and the horizontal force at the elastic center can be determined using this relation. So MO is equal to minus integration m dash dx by EI divided by integration dx by EI. Then after cancelling EI and EI, the equation minus integration m dash ds divided by integration dx. Then the vertical force at elastic center O is equal to minus integration m dash x dx by EI divided by integration x square dx by EI. After cancelling EI and EI, the equation becomes VO is equal to minus integration m dash x dx by integration x square dx. Similarly, HO is the horizontal force at the elastic center O, and this you can find out using this relation. This is minus integration m dash y dx by EI divided by integration y square dx by EI. Then after cancelling EI and EI, so this is equal to minus integration m dash y dx divided by integration y square dx. So using this formula, so you can find out what is the moment and what is the vertical force and what is the horizontal force at the elastic center. First you find out the denominator value, integration dx, integration x square dx and the integration y square dx. First find out the integration dx. Here the integration limit is minus 15 and here the integration limit is plus 15, because this is the elastic center. So you are taking elastic center at the origin, and this is the x axis and this is the y axis. So this side is negative and this side is positive. So here you have to integrate from minus 15 to plus 15, so that you can find out what is the integration of dx between the fixed arch A and B. So integration of dx is equal to minus 15 to 15 integration limit into dx. Then after taking the integration of this x minus 15 to 15, so this is equal to 30. Integration of dx is equal to 30. Similarly, find out the integration of x square into dx. So this is also minus 15 to 15 x square into dx. Then after taking the integration x cube by 3 and minus 15 to 15, then after putting the value, so the integration of x square dx is equal to 2250. Then take the integration of y square into dx. But we know y is equal to 2 minus 1 by 37.5 x square. So put this expression here, y square 2 minus x square by 37.5 whole square into dx. Take the integration of this expression, and the integration limit is take minus 15 to 15. Then after taking the integration and putting the integration limit, the value is 96. So this is the integration of dx value. This is integration of x square dx value. This is the integration of y square dx value. So here you got integration of dx, integration of x square dx, and integration of y square dx. Then find out the integration of m dash dx, and find out the integration of m dash x dx. Then find out the integration of m dash y into dx. Then after getting this integration, then you can find out the moment, and the vertical force and the horizontal force are the elastic center O. So here you find out the integration of m dash dx. For integration of m dash dx, this portion, for AD portion the moment is 0, and for DB portion the moment is minus 240 into 9 plus x. This is for AD portion the moment is 0, and for BD portion the moment m dash is equal to minus 240 into x plus 9. Integration of m dash dx, for AD portion the moment is 0, plus for BD portion the integration limit from minus 9 to 15. So here the integration limit from this to this. So here this is origin x axis, this is y axis. So this is negative side of the x axis. So here this length is minus 9, and here the positive side the x axis is plus 15. So here you take the integration limit from minus 9 to 15 for dB portion. So integration m dash dx is equal to 0 plus integration limit from minus 9 to 15 and minus 240 into x plus 9 into dx. Then after taking the integration of this expression, then integration of m dash dx is equal to minus 69120. Then find out the integration of m dash x into dx. So for AD portion the moment is 0, so this is 0, and for BD portion the moment is, this is moment minus 240 into x plus 9, and the integration limit is from minus 9 to 15. So here 0 plus minus 9 to 15 integration limit minus 240 into x plus 9 into x into dx. Then after taking the integration of this expression, so here you get the integration m dash x dx is equal to minus 483840. Then find out the integration of m dash y into dx. Here the m dash for AD portion this is 0, and for BD portion the moment is minus 240 into x plus 9. So the integration of m dash y dx is equal to 0 plus integration minus 9 to 15 minus 240 into x plus 9 into y into dx. Then after taking the integration and putting the integration limit, integration m dash y dx value is equal to 11247.71. Then after getting the m dash dx, m dash x dx and m dash y dx, then integration of dx, then integration of x square dx, then integration of y square dx, then you can find out what is the moment and vertical force and horizontal force are the elastic center. So the moment at the elastic center O, MO is equal to integration m dash dx by integration dx. Then after putting the integration of dx and the integration of dx, then the value MO is equal to 2340 kilonewton meter. Then find out the vertical force or vertical reaction at the elastic center O. VO is equal to minus integration m dash x dx by integration x square dx. Then after putting the value of integration minus integration m dash x dx and integration x square dx, after simplifying, the vertical reaction at the elastic center O is equal to 215.04 kilonewton. Then find out the horizontal force at the elastic center O, or horizontal reaction at the elastic center O. This is equal to minus integration of m dash y dx divided by integration of y square dx. So here you know the integration of m dash y dx and the integration of y square dx. Then after putting this value, then this is equal to minus 117.16 kilonewton. So this is the moment at the elastic center O. This is the vertical force or vertical reaction at the elastic center O. This is the horizontal force or horizontal reaction at the elastic center O. Here the horizontal force you got minus 117.16 kilonewton. So this horizontal force, here you have to change the direction of the horizontal force or horizontal direction. This is the direction of the horizontal force at the elastic center O, but you got the negative sign. So here you take the horizontal force direction is towards right. So here the horizontal force at the elastic center is HO is equal to HO is equal to 117.16 kilonewton, and the direction is towards right. Then after knowing the MO, VO and HO, then you can find out what is the reaction at A and what is the reaction at B. So the reaction at A, that can be find out using this equation. So the reaction at A is equal to MA, MA is equal to M dash plus MO plus VOX plus HOY, because already you know the MO, VO and HO, and you know the coordinates XY from the elastic center. You know the coordinates of the point A. You can find out what is the moment at the support A. MA is equal to M dash plus MO plus VOX plus HOY. Similarly, VA is equal to VO. So what is the vertical reaction at elastic center O? This is equal to the vertical reaction at the support A. Similarly, what is the horizontal reaction at the elastic center O is equal to the horizontal reaction at the support A. HA is equal to HO. And the moment at the A, that you can find out using this expression. MA is equal to M dash plus MO plus VOX plus HOY. But at A, the coordinate of the A is equal to, with respect to the elastic center, so this is the elastic center and this is the origin, and this is the x-axis and this is the y-axis. What is the coordinate of A? Because this is the 2 meter. From elastic center to the crown is 2 meter and the total rise is 6 meter. So what is the vertical coordinate of this support A? This is minus 4 meter, because this is positive y-axis, this is negative y-axis. So then y coordinate of support A is equal to minus 4 meter, and the x coordinate of support A is equal to minus 15 meter, because this is the origin, this is positive x-axis, this is negative x-axis. So here this is minus 15, the x-axis minus 15, and the y-axis this is minus 4. So after putting the x-axis and y-axis of support A, then you can find out what is the moment at the support A. The moment that you can find out at the support A, MA is equal to M dash plus MO plus VOX plus HOY. But the coordinate of A is equal to XA is equal to minus 15 meter and YA is equal to minus 4 meter. Then after putting these coordinates and the MO, VO and HO, then you can find out what is the moment at the support A. Because M dash, you know, M dash is equal to 0. So at support A, the moment is equal to 0. This is so at support A, the moment due to external loading, this is equal to 0. Here there is no moment due to external loading, so m dash is equal to 0. M dash is equal to 0, and you know what is the value of MO, VO and HO, and you know the x coordinate of A and y coordinate of A. Then after putting this, you can find out what is the moment at the support A. MA is equal to 0 plus 2304 plus 215.04 and the coordinate minus 15 plus minus 117.16 into the y coordinate, this is minus 4. After simplifying this equation, MA is equal to minus 452.96 kilonewton meter. So here you got the negative value of the moment, so the tension you get outside the arch. The tension is outside. Then the VA and HO that you can find out, because you know here the VO, this is equal to 215.04 kilonewton and the HO is equal to 117.16 kilonewton, and towards right, so the VA is equal to VO and HA is equal to HO. So VA is equal to 215.04 kilonewton and HA is equal to HO is equal to 117.16 kilonewton, and the direction of the horizontal force is towards right. So this is the forces or the reactions at A, that is MA, VA and HA. MA is equal to minus 452.96 kilonewton meter and VA is equal to 215.04 kilonewton, HA is equal to 117.16 kilonewton. Then find out what is the reaction at B. So first you have to know what is the coordinate of the B with respect to the elastic center. So here this is the elastic center and this is the origin and this is the x-axis and this is the y-axis. So you have to find out what is the reaction at the support B. So first you have to know what is the coordinate of the support B. So here this is the x-axis and this is y-axis. The y coordinate of the support B, this is minus 4 meter, and the x coordinate, this is plus 15 meter. This is the positive x-axis. So the x coordinate is 15 meter plus 15 meter, and the y coordinate, this is equal to minus 4 meter. This is negative side from the origin. So y is equal to minus 4 and x is equal to plus 15. So at B, xp is equal to 15 meter and yb is equal to minus 4 meter. Then after putting this coordinate and the moment MO, VO and HO and M dash, then you can find out what is the moment at the support B. So but here you know the moment due to external loading, so this is equal to minus 240 into 24, because here you see so M dash is the moment due to the external loading. So at the support B, the moment due to external loading is equal to 240 into the perpendicular distance is equal to 24. 240 into the perpendicular distance 24. So the moment due to the external loading at the support B is equal to minus 240 into 24. So M dash is equal to minus 240 into 24. This is equal to minus 5760 kilonewton meter. Then the MO you know, and VO you know, and the HO you know, and you know the x coordinate of the support B and y coordinate of the support B. Then after putting the all the value, then the expression MB is equal to minus 5760 M dash, this one is M dash, plus 2304, this one is MO, then VOX, so VO is equal to 215.04 and x is equal to 15, plus HO and y, HO is equal to minus 117.16 and y is equal to minus 4. Then after simplifying this expression, so the MB is equal to 238.24 kilonewton meter. But here the moment you got at the support B, this is positive value, so the tension inside. So here you get the tension inside the arch. Then the vertical reaction at B, that you can find out. So what is the load is acting on the fixed arch minus the vertical reaction at the A. So here you got the vertical reaction at A is equal to 215.04 kilonewton, and that load is acting, this is 240 kilonewton. So the vertical reaction at B, that is the summation of vertical force is equal to 0. So VA plus VB is equal to the total downward load. So the downward load is equal to 240. Then you can find out VB is equal to 240 minus VA. So 240 minus 215.04. So this is equal to 24.96 kilonewton. This is the vertical reaction at B. Then you can find out the horizontal reaction at B. So the horizontal reaction at B is equal to minus HO. So what is the reaction at the support A? So here the reaction, the horizontal reaction at the support B, this is in opposite nature, that is and the magnitude is same. The HP is equal to minus HO is equal to 117.16 kilonewton. The direction of the horizontal reaction at B is left side direction. This is 117.16 kilonewton magnitude, and the direction is left side. Then find out the what is the moment at the D point, at the loading point. So where the load is present, so find out what is the moment. So this is the D point and this is the C point. This is the crown and this is the loading point. So find out what is the moment at the point D. The moment at D is equal to, at the load point, what is the coordinate of the point D? So here the x coordinate is equal to minus 9 meter. X is equal to minus 9 meter. But here you have to find out the y coordinate. By using this equation you can find out the y coordinate. So the y is equal to h by 3 minus 4h by l square into x square. So here you know the rise of the arch is 6 meter and the length of the arch is 30 meter and x is equal to minus 9 meter. So using this expression, so you can find out the y coordinate. The y coordinate is equal to 2 minus x square by 37.5 is equal to 2 minus 9 square by 37.5 is equal to minus 0.16 meter. So this is the y coordinate. The y coordinate of the point D is equal to minus 0.16 meter. But the moment at the point D is equal to 0. That is the moment due to the external loading is equal to 0. M dash is equal to 0 because the load is present at the point D. So the perpendicular distance of that load at the same point, this is equal to 0. So the moment due to the external loading is equal to 0. M dash is equal to 0. Then using this formula you can find out what is the moment at the point D. So MT is equal to M dash plus MO plus VOX plus HOY. So M dash is equal to 0 and MO you know, VO you know and HO you know, and you know the X and Y coordinate of the point D. So after putting the X and Y coordinate and MO, VO and HO and M dash, you can find out what is the moment at the loading point. So moment at D is equal to 0 plus 2304 plus 215.04 into minus 9 plus minus 117.16 into minus 0.16. Then after simplification, MD is equal to 387.3856 kilonewton meter. But here you got the moment at the loading point is positive, so that the tension inside in the fixed arch. Then find out the moment at the crown. So at crown, so the x is equal to 0 and y is equal to 2. This is the crown. What is the coordinate at the crown with respect to the elastic center? What is the coordinate of the C point or the crown with respect to the elastic center? Because this is the x-axis and this is the y-axis. So here the x-axis is 0 and y-axis, this is y from with respect to O. So what is the y distance? So y distance is equal to 2 meter and x distance is your 0. So x coordinate of C point is 0 and y coordinate of C point is 2 meter. X coordinate, x is equal to 0 and y is equal to 2 meter. Then you can find out what is the moment due to the external loading at the crown. So this is equal to minus 240 into 9 minus 2160 kilonewton meter. So here you have to find out what is the moment due to the external loading. That is, this is the crown and at the crown you have to find out what is the moment due to external loading, and this perpendicular distance is your 9 meter. So what is the moment here? Minus 240 into 9. So this is the moment at the crown due to the external loading. Here you can find out the MC is equal to M dash plus MO plus VOX plus HOY, and here you got the M dash is equal to minus 240 into 9 is equal to minus 2160 kilonewton meter, and the MO, VO and HO you know, and here you got the coordinate of the crown X and Y. Then after putting all the value you can find out what is the moment at the crown. So MC is equal to minus 2160 plus 2304 plus 215.04, and the X coordinate is 0 plus minus 117.16, and the Y coordinate is 2. Then after simplifying this equation, MB is equal to minus 90.32 kilonewton meter, and here you got the negative value moment. So the tension occurs outside the arch. So at the crown the tension occurs outside the arch. So these are the process. So you have to find out the moment at any section in the arch. After getting the moment and the vertical force and horizontal force at the elastic center, then you can find out the moment at any section in the arch. First you have to find out the moment at the support A by taking the MO, VO, HO, and you have to find out what is the coordinate of the support A, and by putting the equation that is the MA is equal to M dash plus MO plus VOX plus HOY. Then after getting that MO, VO, HO and the XY coordinate of the support A, and after getting the moment due to the external loading M dash, so you can find out what is the moment at the support A. Then the vertical reaction and horizontal reaction, that is same as you got at the elastic center, that is VO is equal to VA and HO is equal to HA. Similarly you can find out at the other support B what is the moment using the equation MB is equal to M dash plus MO plus VOX plus HOY. Then after knowing the coordinate of the support B X and Y, and you know what is the MO, VO and HO at the elastic center, then after knowing the M dash, that is the moment due to the external loading, then you can find out what is the reactions at the support B, what is the moment MB, and what is the vertical reaction at VB, and what is the horizontal reaction at HP, that you can find out. So the vertical reaction that VB you can find out by taking the summation of vertical force is equal to 0. From that equation you can find out the VB. Then HP is equal to the minus of HO. HB is equal to minus HA or minus HO. Then you can find out the moment at any other section using the equation M is equal to M dash plus MO plus VOX plus HOY. You have to know the coordinate of that point, then you can easily find out what is the moment of that section. Now you are clear how to solve the symmetric parabolic fixed arch.